Okay, here we are, Unit 3, Lesson 3. We're going to talk about quadratic relations, quadratic graphs. So we have a couple of examples here. We have a table of values, and a table of values has to be filled in with an equation. If we look at the first one, we put that information on a graph. We'll set up our scale, 2, 3, a little bit of a scale on our graph, and then if we remember how to put points on, we'll put all our points on the graph. So -2, -3 on my table means I go over -2 and I go up 3 and I put a point. And -1, 0 means I go to the left -1 and up 0, so I put a point. And 0, 1 means I stay in the center and I go down 1. And 1, 0, go over 1, up 0. And 2, 3, over 2, up 3. And once I put all those points on, I join them up nicely with a curve, and I get a graph that looks like that. So when I have a table already made, I can go ahead and put the points on the graph. When I don't have a table that's all filled in, I have to take the equation I'm given and substitute the given numbers for x. So I'll take -2 and put it in for x. So I have 2 times -2 squared minus 3, and I'll get an answer. And -2 squared is 4, times 2 would be 8, take away 3 gives me an answer of 5. And I do the same with the next x number. Take out the x and I put in the new x number. And I do bad math and calculate with brackets first, the exponents, -1 to the exponent 2 is 1. Times 2 is 2, take away 3 is -1. And I keep going with each new x value, getting the answers. 4 minus 3 is 1. 5, and I'm going to put them on the graph. Same idea, I'll put a scale. So I have -2 and 5. And I have -1, -1, 0, -3, 1, and -5, and 2, and 1. So I'll join up my points and get something that looks like that. So you can see the two graphs I've made have basically the same shape. One's a little skinnier than the other, and the other's a little bit wider. The graph of a quadratic relation is this shape. This shape is called a parabola. It's a U-shaped symmetrical curve. So by plotting points on a graph, if we see this shape, we know that the relationship is a quadratic if it has a parabola shape. Some special terms that go along with a quadratic. One is the vertex. The vertex is the lowest or the highest, depending on whether it's the lowest or the highest, is the lowest or the highest point. Other terms that go along with a quadratic is the direction of opening. This parabola opens up. So direction of opening and vertex, two terms that go along with a parabola, a quadratic relation. And get my next page to go. Why won't my next page go? Let's try that again. There we go. So which of the following relations are quadratic? So if we go back and look at our graphs, this equation in B that gave us a quadratic had a special number in its equation, an exponent of 2. Anytime an equation has an exponent of 2, it will be a quadratic. So A is a quadratic because it has an exponent of 2, and C is a quadratic because it has an exponent of 2 as well. So if I want to know if something is a quadratic function or a quadratic relation, I can look at the graph and watch for a parabola shape, or I can look at the equation and look for an exponent of 2.